So, the crankshaft is carried in a position that's parallel to the longitudinal axis of the crankcase and is generally supported by a main bearing between each throw. The crankshaft main bearings, must be supported rigidly in the crankcase. This is usually accomplished by means of transverse webs in the crankcase, one for each main bearing. These webs form an integral part of the structure and, in addition to supporting the main bearings, they add to the strength of the entire case. The crankcase is divided into two sections in a longitudinal plane. This division may be in the plane of the crankshaft so that one half of the main bearing and sometimes camshaft bearings are carried in one section of the case and the other half in the opposite section. Another method is to divide the case in such a manner that the main bearings are secured to only one section of the case on which the cylinders are attached, thereby providing means of removing a section of the crankcase for inspection without disturbing the bearing adjustment. The crankshaft is basically the backbone of the reciprocating engine. It's subjected to most of the forces developed by the engine. Its main purpose is to transform the reciprocating motion of the piston and connecting rod into rotary motion for rotation of the propeller. The crankshaft, as the name implies, is a shaft composed of one or more cranks located at specified points along its length. The cranks, or throws, are formed by forging offsets into a shaft before it is machined. Since crankshafts must be very strong, they generally are forged from a very strong alloy, such as chromium nickel molybdenum steel. So, a crankshaft may be of single-piece or multi-piece construction. The four-throw construction, can be used either on four-cylinder horizontally opposed or four-cylinder inline engines. The six-throw shaft is typically used on six-cylinder inline engines, 12-cylinder V-type engines, and also six-cylinder opposed engines. And crankshafts of radial engines may be the single-throw, two-throw, or four-throw type, depending on whether the engine is the single-row, twin-row, or four-row type. No matter how many throws it may have, each crankshaft has three main parts: a journal crankpin and crankcheek. Counterweights and dampers, although not a true part of a crankshaft, are usually attached to it to reduce engine vibration. The journal is supported by and rotates in a main bearing. It serves as the center of rotation of the crankshaft. Plus, it is surface hardened to reduce wear. The crankpin is the section to which the connecting rod is attached. It is off-center from the main journals and is often called the throw. Two crank cheeks and a crankpin make a throw. When a force is applied to the crankpin in any direction other than parallel or perpendicular to and through the center line of the crankshaft, it causes the crankshaft to rotate. The outer surface is hardened by nitriding to increase its resistance to wear and to provide the required bearing surface. So, this reduces the total weight of the crankshaft and provides a passage for the transfer of lubricating oil. On early engines, the hollow crankpin also served as a chamber for collecting sludge, carbon deposits, and other foreign material. Centrifugal force would throw these substances to the outside of the chamber and keep them from reaching the connecting rod bearing surface. But, due to the use of ashless dispersant oils, newer engines no longer use sludge chambers. On some engines, a passage is drilled in the crank cheek to allow oil from the hollow crankshaft to be sprayed on the cylinder walls. So, the crank cheek connects the crankpin to the main journal. In some designs, the cheek actually extends beyond the journal and carries a counterweight to balance the crankshaft. The crank cheek has to be of sturdy construction to, get the required rigidity between the crankpin and the journal. In all cases, the type of crankshaft and the number of crankpins must, correspond with the cylinder arrangement of the engine. The position of the cranks on the crankshaft in relation to the other cranks of the same shaft is expressed in degrees. The simplest crankshaft is the single-throw or 360-degree type. This type is used in a single-row radial engine. It can be constructed in either one or two pieces. Two main bearings, one on each end, are provided when this type of crankshaft is used. The double-throw or 180-degree crankshaft is used on double-row radial engines. In the radial-type engine, one throw is provided for each row of cylinders.